So hi everyone, today I'm recording myself for this alcohol phenol ethers chapter. Specifically the target is to make sure that you don't go unprepared for your exam. But don't worry, I'm going to teach this chapter one more time in the classes as well. But before your exam, I believe a little bit of heads up will be better for you, and I will be also able to manage all the things together. So I'll be sticking to the NCRT over here, and I believe that is what you need for your school examination purposes as well. Now, as you can see, let's start with the first thing, which is the preparation of alcohol, right? Now, if you notice, in the preparation of alcohol, this particular mechanism is very, very important for us. Okay, so I will just show you what is this preparation method talking about. So, for those who have the entire alcohol phenol ether chapter, guys, you can go for the electrophilic substitution segment. You will be able to see every single thing I have already taught you. There will be a little bit of modification in the reactants, I would rather say. Like for nitration, you just need dilute nitric acid, not mixed acid anymore. For bromination, you need Br2 in carbon disulfide or any non-polar solvent. So there is a little bit of reagent differences in there, just because phenol, like the OH group, is an electron donating group. But other than that, I believe you will be fine with the chapter. Now we'll be mainly focusing on the preparation reactions over here. So the main and the most important thing, which also came in this last year CBSE examination 2024 paper, means the last year paper also, this exact thing came in, which is about the preparation from alkene. Okay, guys, we know that this reaction is a very simple reaction actually, but the mechanism, there are only a few mechanisms which is there in the NCRT, and we need to go through all of them actually. This particular question comes for 3 marks, and it's like there is a near about 100% chance of this question coming in. Okay, I'm not saying 99%, it's 100% coming in your exam if you have this part in the school examination. Now, what is the reaction mainly? Let's say you have an alkene and you want to make an alcohol out of it. So the mechanism is you just give water in presence of slightest amount of acid. Then what happens? Then you get alcohol. Now, how do you get it? See, it's just a simple Markovnikov method addition. Whenever there is an addition on alkene, you know that follows Markovnikov method, right? So according to Markovnikov method, whoever is already having more hydrogen, that guy gets the hydrogen. So you know water breaks into H plus and OH minus, don't you? So whoever already has more hydrogen, that guy gets the hydrogen, and the other guy gets the OH. So eventually your product becomes CH3, CHOH, CH3. Simple. That's how you make an alcohol. But actually the mechanism of this reaction, it's a little bit elaborated in the book, and that is what we have to learn actually. Okay, so the reaction is pretty simple. By the way, guys, remember, any unsaturated system, if I'm following any addition reaction like the previous one, then it undergoes Markovnikov addition. Okay, I hope you remember Markovnikov and the anti-Markovnikov rule. Okay, so this is something that we learned in grade 11th as well. It follows the carbocation mechanism. Okay, now anyway, if I go for the mechanism of this reaction, first, how the water and H plus are reacting, that's the first step. So water and H plus. Now you know what, this H plus, it's an electrophile, correct? And water is a neutral nucleophile. So as a result, this lone pair will go and attack this H plus, and you will get H3O plus. How does H3O plus look like? It's called coordinate covalent bond. You have a chapter in this grade 12 which is called coordination compound. This is how H3O plus looks like, hydronium or oxonium, correct? Now the next step, actually from here the reaction starts actually, but you have to do the first step. Every single thing I'm writing, you have to write it. Okay, in the book you will be able to see every single step has a name as well. Make sure you try to follow every single word by word what is written in the book as the headings and everything, right? So I'm gonna go for the protonation of alkene. This is what's gonna happen in the reaction, but they might write in the book that protonation of alkene to make a carbocation or something like that. Just try to follow that as much as possible. But any which ways, conceptually protonation of alkene is enough to write. Now you take this alkene and then you react this guy with our H3O plus. Now what will happen? See, as this bonds are made up of electron, which we call as pi electron, because these are pi bonds, right? So the pi electrons are actually acting like a nucleophile here. And electrophile, so it's clearly visible, so it will go and take the hydrogen from here. Now once it takes the hydrogen, CH3, CH, CH2, there can be two products formed. Let's call it carbon number 1, carbon number 2, carbon number 3. Now let's say if the attack is happening from the double bond, the double bond is shared by both carbon number 2 and carbon number 3. So that means both of them has a claim to the hydrogen. Now let's see, we can write one of the structure as carbon number 2 getting the hydrogen and carbon number 3 getting nothing, that means a carbocation. And the other possibility that can happen is the carbon number 3 getting the hydrogen and 2 getting nothing, means the carbocation, right guys? So the double bond is shared by 2 and 3 both, so both have equal right to take the hydrogen, right? Now you can see out of these two systems, if you notice this guy, this carbon, it is a 1 degree carbocation, right? And this is a 2 degree carbocation. Now we know the carbocation stability order goes like 3 degree, 2 degree, 1 degree. So as a result, as 2 degree is more stable than 1 degree, so definitely this is gonna be my major product. Now if that is my major product, my second step of the reaction goes by that particular product only. So let's go for the step number 2. Step 2. Now you write step 2 as addition of water on carbocation, something like that. Addition of, we can write nucleophilic addition of water, anyway, water on carbocation. Try to follow whatever heading that the book is given, but any which ways, it's science we are talking about, so the mechanisms are the one that matters. Make sure that you're practicing the mechanism at least 2 to 3 times, okay, before you go for the examination. You have to get this perfectly correct, and this will be a 3-marker question, like I said, and this will 100% come, like I said as well. So now what will happen next is the water that we have, that water, this is, this is a neutral nucleophile because it has lone pair, and you can clearly see an electrophile. So this is my electrophile, this is my nucleophile. I've been keep on telling you, in organic chemistry it's all about finding out the electrophile and the nucleophile, right, and then make them attack with each other. Now once you do that, then the product that gets formed is CH3, CH, CH3, then you have OH2 plus, correct, because the lone pair has been given. Again, coordination compound, coordination bonding, anyway, you get this product. Now here's the last step, step number 3. Step number 3 is called what should I say, so this hydrogen is going to be taken by water, so you can take acid base reaction, acid base reaction, or deprotonation of water, something like that. Protonation means hydrogenation, so deprotonation means removal of hydrogen or something like that, right? So CHO H plus CH3. Now what actually happens is, the main point is here the water's lone pair, it just goes and takes the hydrogen back. It's an acid base reaction, isn't it? This guy is acting like an acid because this is donating hydrogen, and water is taking hydrogen, so it's acting like a base. So from there you get this final product. Now you can see that we have reproduced the hydronium ion which we started with. So this is the entire mechanism. Now fine tuning this, like going through the headings and stuff, that you try to do according to the book which is there. Okay, I believe we have understood the entire process. Now this is what we have. As you can see, every single step has a heading. Just try to follow that heading. Acha, this is something we are done with. Now we go for the next reaction, which is hydroboration oxidation. Again, from this chapter, those who have this chapter in the reaction in the examination, from this chapter, mainly what they do is they give you short notes on writing on these topics, either short notes or conversions. Now, conversions can be a little bit tricky when the question comes from these particular segments. Okay, now let me show you what kind of conversions comes from here. Okay, the next thing that we are going for is hydroboration oxidation. We're gonna try to understand the logic behind it. Okay, what is the logic behind we learning this topic? Hydroboration oxidation. Okay, now see, hydroboration oxidation, what is the purpose of this? What is the purpose of this reaction? Definitely we want to form alcohol because that's what we're learning. But the main point about hydroboration oxidations, the main purpose of hydroboration oxidation is to make terminal alcohol. Now, what do I mean by terminal alcohol? If you notice, when we were trying to add water in alkene, we got an internal alcohol. We got this as the major product because it follows the Markovnikov rule. But what if I do not want the OH in the middle carbon? I want it in the terminal carbon. What if I want that? Now, that is not supposed to happen by addition of water. So for that, I need a specific reaction to get it in the terminal position. Now, so first I'm gonna give you the reaction mechanism. The reaction line. So this, so what are we trying to make? We are trying to make terminal alcohol. So that means CH2, CH2O. If you can understand, guys, we want the anti-Markovnikov product. Okay, we want the anti-Markovnikov product. But then again, anti-Markovnikov is only applicable for your HBr, correct? None other than HBr. So that's why we cannot use anti-Markovnikov here. So what we generally do is we add BH3, borane. Sometimes they write B2H6 as well. Just a dimer of borane, that is called diborane. You can write any one of them. BH3 in tetrahydrofuran. Tetrahydrofuran is like this molecule is called furan. Tetrahydrofuran means you have added up hydrogen in there. Like you saturated it. Okay, no double bonds. Tetrahydrofuran is an ether. Every single time you have done any reaction, mostly we use the solvents as a volatile solvent. Ethers are very volatile, just like sanitizer. Chloroform, carbon tetrachloride, they are also used as solvent just because they are very volatile. When somebody is volatile, what happens is in the end of the reaction, the solvent evaporates on its own and it's very easy to get the product on the pure form. So the solvents can be separated very easily, right? But if I use water or something like that, they don't evaporate that easily. So I need to heat the system, the product, in order to take out the water, which again can break the molecule, correct? That's why we avoid to do that. Now anyway, if I give BH3 in presence of THF, that is step number 1. Step number 2 goes like H2O2 OH minus H2O2 OH minus. These two steps you have to do in order to get this final product. Okay, BH3, this is why it's called hydroboration, because boron is involved there. Now the mechanism is given in the book and I'm gonna show you the mechanism for this reaction as well. But this is the main thing you have to remember, that to get a terminal alcohol we have to use hydroboration oxidation. Okay, now let's say I'm giving you an example here, the mechanism here, sorry. Mechanism here. All right. So for that, what you have to do is generally, first you draw the molecule, the alkene. Now you know that boron, this molecule, if I draw it here, boron comes under Lewis acids. If you notice, boron has only 6 electrons around it. 1, 2, 3, 4, 5, 6, right? So boron comes under Lewis acid, just like AlCl3. Similarly, boron is also a Lewis acid like aluminium, correct? Again, The pi electron, just like the previous reactions, the pi electron over here acts like a nucleophile. And Lewis acids, we already know they are incomplete octet people, so it needs 2 electron in order to become octet, correct? So it is an electrophile eventually. Neutral electrophiles, guys. Lewis acids are neutral electrophiles. So now this pi bond, it attacks this boron. As a result, the next molecule you get over here is, again guys, mechanism is all about practicing, correct? So again guys, I think I don't have to tell you, the moment it attacks, there can be 2 possibilities of carbocation getting formed. One is in the internal, one is the terminal, just like the previous question we have done. One carbocation can form here, one carbocation can form here. But this particular product that I have written right now, this is the best product, this is the major product, because the carbocation is internal carbocation, correct? Now after that, for obvious reason, this hydrogen will come and join the positive charge just to make it stable. So you'd get CH3, CH2, CH2, BH2. Simple. So guys, now if you notice, since the beginning to this step, what exactly has happened? Boron has 3 hydrogen. 1 hydrogen got substituted by this entire group. If you notice, if I simply try to handle this thing, boron was connected with 3 hydrogen in the beginning, right? 2, 3. Now it is connected to 2 hydrogen, 1 group, 1 alkyl group. Let's call this alkyl group as R, just for our convenience. Now guys, if I do the reaction 2 more times, why 2 more times? Because 2 more hydrogens are present. So can I get this product in the end? All the 3 hydrogens got substituted by R group. What is the R group? This CH3, CH2, CH2 group. Now this was the major part to understand. The next step is, now the moment you give H2O to OH minus, now they don't show you the mechanism here, and I'm gonna also skip the mechanism part of this H2O to OH minus for the time being. But in the advanced classes, or even in the regular classes when I will teach you this chapter, that time I will definitely mention this topic, like how the reaction happens. This particular reaction is actually the part of oxidation. The name of the reaction is hydroboration oxidation, if you notice. The first step was hydroboration. Till here it was hydroboration. Now this is the part of oxidation. Now here what happens is, the R groups, they get separated at ROH, and these groups can convert into OH, OH, OH. Okay. Now this part is also not mentioned in the group, not mentioned in the book. How does that happen? And I'm also gonna skip this part. So this part you just have to try to remember. Just practice these reactions quite a few times. Now ROH, guys, what was the group R? CH3, CH2, CH2, OH, CH2, CH2, OH. That's your final answer. Now you have seen that, guys. You got the terminal alcohol. This question also comes with the mechanism for 2 to 3 marks. But this is something you have to make sure that you 100% remember, okay? That was your hydroboration oxidation. Now let's move on to the next reaction which is there in our syllabus. See, in a way to get opposite of Markovnikov rule. So as you can clearly understand, it's the anti-Markovnikov product, but we cannot use the anti-Markovnikov mechanism there, right? Because that needs HBr. Now, from here onwards, things will be much more easier for you to understand. Always remember, whenever there is a metal involved, that means it's always a reduction reaction. And before we get into the reduction reaction, always remember, lithium aluminium hydride and sodium borohydride, these are the 2 strongest reducing agent out there in organic chemistry. And if you ask me, sir, between these 2, who is stronger? The answer is this. Now, you might be asking me, sir, why is this like this? So, guys, if you have learned electrochemistry, and if you haven't learned, when I will teach you electrochemistry, there I will show you that lithium is the most reducing agent. Its reduction potential is 3.05 electron volt. That's the highest reduction potential, lithium. So lithium, technically, it's the best reducing agent out there. That's why lithium aluminum hydride is the best reducing agent as well. Now, guys, there is something you need to understand in order to understand this reduction and the oxidation chain, which will be helping you throughout organic chemistry now. So go for the heading as oxidation chain or oxidation reduction chain. If you're watching this video, guys, make sure you're making notes with it. By practicing, the mechanisms will be completely fine. Okay, make sure you're practicing it quite a few times. I hope all of you have started making magic notes where you have been writing down all the reagents and everything together, right? Now let's go for oxidation reduction reactions. Guys, always remember, let's say we start with an alkane, which is CH3. This is what? This is an alkane. When you oxidize an alkane, what really happens? You have oxidized it. Guys, oxidation means addition of oxygen. Oxidation means addition of oxygen. If oxidation means addition of oxygen, then can I say the next product will be this? Because nothing else has happened other than just adding an oxygen. So guys, on oxidation of alkane, you get alcohol. Now, if you further oxidize it, what will happen next? Guys, again, removal of hydrogen is also oxidation, right? Removal of hydrogen is also oxidation. So now what I'm going to do is I'm going to remove one hydrogen from here, one hydrogen from here, one from the oxygen, one from the carbon. And the product I will get is CH3CHO. What is this, guys? This is aldehyde. Right? So we take the hydrogens from consecutive two positions. Okay? So we get aldehyde. Now, by the way, this alcohol over here, guys, if you notice, the OH is connected to a carbon, which is actually a 1 degree carbon, correct? Because it is connected to only one carbon. So it's a 1 degree carbon. So we call this thing as 1 degree alcohol. By the way, if I have a 2 degree alcohol, then what will happen? Like this. I have a 2 degree alcohol. Because this carbon now containing the OH is now holding on to 2 carbons. So that means it is going to be a 2 degree alcohol. Now under these circumstances, again guys, don't forget the root. One hydrogen you're going to take from here, one hydrogen you're going to take from here like before. And you will get this time not an aldehyde but a ketone. CH3CO, CH3. So guys, when you are oxidizing a 1 degree alcohol, you get an aldehyde. From 2 degree alcohol, you get a ketone. Okay. Now it's a removal of hydrogen we have seen. Now the next step. Next step is, again, if I oxidize it. Let's say I have taken the now this time, again, addition of oxygen. Alternative, okay? Addition of oxygen. If I do the addition of oxygen, then again, now from here, you will get a CH3COOH, carboxylic acid. You can see that there was only one oxygen here, but there are 2 oxygens in here. So we get a carboxylic acid here. That's the main thing. Now guys, how do I remember this? See, I can remember it logically, but for examination purposes, what I do is, if you tell me what is the name of the first chapter for your organic chemistry, haloalkane haloarynes, okay? What's the name of the second chapter? That is alcohol phenol ether. See, the second chapter is here. What's the name of the third chapter? Aldehyde, ketone, carboxylic acid. So we just follow the chapter names one by one and you'd get the order correct. Haloalkane haloarynes doesn't come under the oxidation chain. Let's go for the alcohol. Then alcohol phenol ether is the second chapter. Third chapter is aldehyde, ketone, carboxylic acid. So see, that's how you can remember this. Now guys, we can do the opposite as well. Can I not say, if this is the oxidation chain, by going backwards, I can call it a reduction chain. So if I reduce carboxylic acid, I will get aldehyde. If I reduce aldehyde, I will get alcohol. If I reduce alcohol, I will get alkane. Correct? This is the reduction. I hope this is clear. If the forward is oxidation, the backward is reduction. Simple like that. Now that's all you have to remember in order to understand the next part here. So if you notice, What have they done? They're writing about it. Lithium aluminum hydride, sodium borohydride are strong reducing agents and this and that. First reaction they have given is, if I reduce aldehyde in presence of hydrogen and palladium, again it's a metal, so you can clearly understand its reduction, or NaBH4, then I will get alcohol. So guys, if you notice in our chain, if we reduce an aldehyde or a ketone, I would get an alcohol. By reduction of aldehyde, I will get a 1 degree alcohol. By reduction of a ketone, I will get a 2 degree alcohol. Correct? So that's what they are going to show here as well, if you notice. Reduction of aldehyde gives you 1 degree alcohol. Reduction of ketone gives you 2 degree alcohol. Simple like that. Reduction of carboxylic acid in presence of lithium aluminum hydride gives you alcohol. Now guys, again let's go for the chain. Now there you see that carboxylic acid is being used. Now if I give lithium aluminum hydride here, so you might think, sir, lithium aluminum hydride should give me aldehyde first. But guys, the point is, it's like a galloping train. Lithium aluminum hydride being very, very strong, it doesn't give you aldehyde. The reaction keeps on going all the way to alcohol. Okay, so it just skips the intermediate steps and it just goes all the way to the alcohol. Okay, so that is very simple as well to understand, I believe. Yeah, that's it. Now we are going to go for the Grignard's reaction. Grignard's reagent. Now what is the story about Grignard's reagent? So guys, Grignard's reagent is, again, these every single reactions that we are learning right now, they are all important for us. Grignard reagent is there in every single chapter again. Grignard reagent. Now what is Grignard's reagent? So guys, the Grignard's reagent is a reaction that help in the concept of ampulang. Ampulang means reversal of polarity. Reversal of polarity. For example, let's say we take an example of CH3Cl. Generally, when you break any compound with CH3, generally guys, you give CH3 plus Cl minus. That is how we always break things. Have you ever seen so far in organic chemistry CH3 getting minus? You have never seen that, just because it never really happens. Now guys, that is the main point. That let's say I want CH3 in negative charge. I want that to be a nucleophile. Now there is no other reaction. There is no other reaction in the entire organic chemistry till date where CH3 is acting like a nucleophile. CH3 minus. That's why Grignard, he came up with this concept. He said that, what if I add a metal with CH3? For under these circumstances, guys, you know, metals can never be negative. So that's why CH3 becomes negative and the metal becomes positive. This particular kind of compounds are called organometallic compounds as well, because organic part is your CH3, metallic part is magnesium. So this kind of compounds comes under organometallic compounds. There are multiple of them, many of them. So target is to, guys, get the CH3 minus. To get the purpose is to get the CH3 as a nucleophile. Now you see what will happen. So this reaction helps me to do step up. Step up means what? Step up means to increase the number of carbon. Just like in haloalkane haloarenes, I have taught you a reaction called Wurtz reaction. There, guys, you have noticed that we have been learning how to increase the number of carbon by 2 times, correct? But here, guys, we are gonna add the carbons one by one. Process is pretty simple. What we generally do is, let's say I have a molecule which is CH3, C double bonded O bond CH3. 3 carbons are there in this molecule. Now let's say I have given CH3 MgBr. Again, guys, here also we give dry ether as a solvent. Again, because it is volatile. Dry because I don't want water in it. Now the CH3 MgBr will break as CH3 plus or minus, minus, and MgBr plus. So guys, now because of this reason, we got our nucleophile. Now I told you in organic chemistry, what do I need to find? Nucleophile and electrophile. So nucleophile to mil gaya. Now what about electrophile? See guys, generally in this carbon oxygen bond, oxygen being more electronegative, it just drags all the electrons of the bonds. Correct? As a result, carbon becomes delta positive. And this is your electrophilic center. What actually happens is the CH3 minus attacks on the carbon. To maintain valency, it breaks the bond because carbon's valency is 4. So it has to break one of the bond, otherwise it will become 5 the moment CH3 attacks over there. Now as a result, the product that you get generally from here is CH3, C, O negative, CH3, CH3. Now the O negative would attract this MgBr plus, so AO minus MgBr plus. That remains as an ionic compound, right? Now if I give water, you know water breaks into H plus and OH minus. So what will happen? This plus will take this minus and this minus will take this plus. So as a result, the product that you will get is CH3, C, CH3, CH3 on the top, OH and MgBrOH. That's your final product. If you have noticed guys, you have started with a 3 carbon system, but we ended up with a 4 carbon system. So this is how Grignard's reaction works. Now guys, do this question on your own and do let me know what is the product coming. Okay, in presence of dry ether. So one, I have to give you this in presence of ether. Also I have to give water as well, right? This is reagent number 1. Reagent number 2 is water. You'll get a 3 degree alcohol. Why 3 degree? Because the alcohol containing carbon is 3 degree. Correct. Okay. So this is how Grignard reaction works, guys. And that will be it for the alcohol preparation. Now I will make another small video on preparation of phenols, and that contains these 4 reactions only. So watch this particular part, and then guys we can record ourselves one more for phenol preparation, and I believe that is there in your exam. So till then, if I cover up, I guess you will be fine, right? Now I believe I want you to go through these topics which I have taught you so far, and make sure you practice them a little bit, the mechanisms and all, and I believe you will be fine with that. Okay, so thank you guys, that will be it for today.